Good morning, majors. So today we're going to go over angle, side angle. We've already gone over side, 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 and side angle, side. And today this is angle, side angle. If two angles and the included side of one triangle are congruent to the two angles and the included side of a second triangle, then the triangles are congruent. That means that every angle and every side is congruent. So I'm going to show you what this looks like. So we're told that this one has one congruency mark and this one has one congruency mark. So these two are congruent. And then the included side, well, let's go at the other angle. So this one has two congruency marks, B, is congruent to this one with two congruency marks, B, or R. So these two are congruent. And then the included side, so the side that's in between, the side that's in between B and C, and the side that's in between T and R are congruent. That's why it has that little dash there. That means that these triangles are congruent. And remember, our congruency statement has to be in order. So it says triangle ABC is congruent to triangle, draw the triangle symbol, and then we have to put it in the same order. But A is the one with no congruency marks. That's the one they started with. So we also have to start with the one with no congruency marks, which is H. B is the one with two congruency marks, so then we have to go to the one with two congruency marks, which is R. And then our last one is T, HRT. The order does matter. So we're going to look at this proof using the angle side angle congruence, ASA. So we should use ASA, hopefully. Angle side angle. So remember, our first statement is just going to be what they're giving us. They're giving us that this ln is, that L to N is parallel to M to O. So not congruent, but since it has these little arrows, and there's two of them, I know that they're parallel to each other. So I'm going to say L to N is parallel to M to O. And my reason is going to be, that's what's given in our diagram, so that's given. Also, my other two sides are parallel, so I can say that's LM and NO. LM with a line above it is parallel to NO, which is given. This is my diagram, so that's what they're giving us. Now, we can prove that the lines are that the angles are parallel. So I know that this angle and this angle are parallel because I have a transversal and I have my green parallel lines, and these are alternating interior angles. So I know this red angle right here is L. So I'm going to put the angle symbol L, M, N is congruent to angle symbol. This one right here, remember, N has to be in the middle. So I'm going to say O, N, M, and that is because they are alternating interior angles. Okay, also we know that the other alternating interior angles are congruent. So we have the purple lines, and the transversal for that one will be this also. And we will have these yellow angles. This is the alternating interior angle, which are congruent. So I'm going to say angle, this one on the left-hand side is going to be angle L, N, M is congruent to angle N, M, O. And those are alternating interior angles also. Now we need one more thing. We have that our two angles are congruent. This one is congruent to this one, and this one is congruent to this one. But we need the included side is congruent. But we know that side is congruent to both triangles because they're sharing it. They're both sharing MN. So I can say that MN or NM, let me change my color. I'm going to say that MN is congruent to itself, And that is always because of the reflexive property. And my last thing, since I know that these two angles are congruent and these two angles are congruent, I know that this triangle is congruent because of angle, side, angle. So now I can write in what I'm trying to prove, which is this. Just write it in right here at 6. And we're going to say because of angle, side, angle, postulate. Is it possible to prove these triangles are congruent by angle, side, angle, specifically by angle, side, angle? And I'll help you guys do one. So this is actually just like the one that we just tried to prove. So let me try to help you do this one. So we have this angle is congruent to this angle. We know that if this is 90, then this one is also 90. So these two angles are equal. But we need the side in between these two angles, in between, and we don't. We have this side right here. So this one would be angle, angle, side. So this one you're going to say no. We would need angle, angle, side, and not angle, side, angle. Let's look at this one. This is very popular. They're going to use a lot of vertical angles. You've got to remember that vertical angles are congruent. They tell you that these two angles are congruent. And then they also give you that these sides are congruent, okay? But remember, our side has to be between my two angles. So if this is one angle and this is a side, we need the other angle to be right here, which it's not. So this one is also a no, actually. This one would also be angle, angle, side. So let me just make that blue again. But this one you can try it out and write them in order. You have A to D to C. Write it in order, the other triangle in the same order to make your congruency statement. Angle, angle, side congruent. So this is our second to the last one. It says if two angles and one non-included side of one triangle are congruent to the two angles and the not included side of the other triangle, then the triangles are congruent. So this one, we want our two angles. It doesn't matter which two angles. I'm going to say A and L are congruent because they both have 2. And then C and D and O are congruent because they have 1. But the side not in between them. So it can't be AC because that'll be angle, side, angle. It has to be the other side. So BC is congruent to OC. Right, that's what they give us. That means that my two triangles are congruent. Everything about them is equal. And I'm just going to write my congruency statement. They started us off. They said triangle ABC. A is the one with 2 congruency marks, has to be equal to the one with 2 congruency marks, which is L. They second B. B is the one with no congruency marks. So ours with no is C. And then they did C, their C is going to be the one with the red congruency mark. Ours with the red is O, LCO. That does matter. Remember, the order matters. Let's go over another proof using now angle, angle, side relation. Angle, angle, side. This is what we're going to try to prove. So it says given these two are parallel and these two are congruent. So this time they're giving it to us, but they're not plugging it in. We have to plug it in. So it says DF is parallel to PL. Put a line above them. And this is given. They wrote it in there, but it is given. And then also FH is congruent to LH. And this is also given. And if I could put that on the same line, I probably would. So DF is parallel to PL. Means that this side, not congruent, but it is parallel. Which means we have alternating interior angles. So if these are our parallel sides and this is maybe my transversal, then I know that this angle is congruent to this angle. So DFH is congruent to HPL. And that is alternating interior angles, just like we did before, almost always. And then we know that FH is congruent to LH. So F to H, this side, is congruent to L to H, this. So we have angle, and then we have a side. We also know that these two angles are congruent, so we're actually going to need 5. Okay, so we know that these two angles are congruent, and I'm just going to say that angle H, but I'm going to have to write it with 3 letters, DHF, is congruent to angle LHP, and the reason why these two angles are congruent is because they're vertical angles. Now our last step is just to rewrite what we're trying to prove. So these triangles are congruent, and we know that they are because we have an angle, and then the very next side. So that is angle, angle, side, because of angle, angle, side postulate. We're going to practice these. We're going to practice all 4 in class. Is it possible to prove these triangles are congruent specifically by angle, angle, side? So we have this angle is congruent to this one. We have this side, AC, is congruent to this side, CD, because it has a dash. We need another angle, and it can't be actually, it could be either angle. But we know these two angles are congruent because they're vertical angles, so we can assume that. So this is angle, angle, side. So you can say, yes, we can prove that. And we're going to put it in order. They are starting at A, which is one with the purple line next to it, which is the D. So triangle D. And then their middle one is B, which is the blue congruency. Our blue congruency is E. And then the last one has to be C. I want you guys to try these, and we will talk about them in class tomorrow. Have a great night.